All right, this is a part 4 of our lecture on chapter 9. So we are just finished up talking about the welding process on joining metals together. It is important for you to know and understand that there is quite a bit more training that's involved to get personnel fully up to speed and performing these processes and making sure that everything is being done and made correctly and in the right way. So, and that's part of what you're going through here as you get work on your associate's degree or your certificates here at Richland to get that training in the different areas that we provide training and educate classes on. So, our next area here on joining these together is going to talk about adhesive joining. Now, adhesives, of course, we are talking about gluing these parts together with different types of adhesives. The adhesive might be glue. We might be talking about epoxies, different types of resins. So, and where we're taking two sheets to overlap them closely for 3/8 of an inch or more. So generally this method will work. The advantage here, of course, is that we can get these bonded together without it using any heat that might either anneal or change the actual chemical properties of the material as well. So when we do and use adhesive joining, cleaning and preparation of parent surface is critical. So oftentimes these have to be wiped down. You need to clean them, make sure that they're free of any type of rust or any type of oils or other contaminants that would cause a bad adhesion between the glue or the material that's being joined together. We also talk about mechanical joining methods here using bolts, rivets, or screws. Again, we don't need heat. They can be held together. We can use a variety of different types of materials depending on what the needs are. So the disadvantage, of course, is those holes can be allow leakage to come through. So there are ways that can be taken care of. Of course, in vibration type aspects, when you got component parts that are vibrating, sometimes screws, nuts, and bolts can work them way loose. Again, there are different joining methods that kind of will help to work on resisting that. And of course, if you are in the if you're working on your degree and the maintenance side, you'll learn more about the different types of fasteners to help resist those particular forces that are going on with that. We also talk about these type of bolts or rivets and screws and mechanical fasteners in terms of location, where those locations also become stress risers. And we also talk about, depending on what the material is, what's referred to as galvanic corrosion, and how galvanic corrosion can play a part in things that are going on outside, and how we can use different materials to be in terms of washers or bolts, where we utilize aspects of galvanic corrosion for those parts to break and fail first. So, all right, so let's talk here a minute about mechanical joining by clenching. So you can kind of see how we've got these two different types of sheet metals being pushed together. There's a plunger and a blank that goes into the blank holder with clamps here, how that's kind of pushed into the actual material. And then of course the indentation here basically mushrooms and creates the button to kind of cinch that and clench that around the object to help hold those together. So this is a very fast process. So when it's set up, so you've got this aspect here, and clenching is a definite way to mechanically join these two parts. However, there's some disadvantages to it as well. Obviously, you're going to have that button that kind of shows. So, depending on what the area, if you need to have raised, or if you can't have the raised or lowered area, that can be a possible problem there too. So, now we're going to get into my favorite, of course, as the machine tool instructor here at Richland. So the machining processes that we can also use on all of these different types of component parts. Now, as we talk about the different types of machining processes that go on, it's important to know as a machinist, so sometimes we are working on forgings, sometimes we're working on castings, sometimes we might actually be working on bar stock or steel and strip. So we may, there's a wide variety of material and forms and shapes of that material that the machinist needs to be aware of. And as we get those, of course, the role of machining is basically to remove that extra material and process it into its final shape. So these machining operations, of course, are turning on the lathe or the mills. We're cutting material away, we're grinding, we're polishing, we're doing all sorts of different handwork with filing. So when we're using a large variety of cutting tools to shape that metal into the final aspect of that. Now, drilling and a drill press is also a uh, common machining method to cut and remove that material as well. So um, not only are we using sharp cutting tools, so we might be using different types of abrasive materials like um, grinding wheels. If we're talking about polishing, we might be using different types of diamond compound. We might be using lapping plates, all sorts of, but other types of abrasives that are more or less going to polish and get the material to be the right size, the right shape, the right surface finish, and the right tolerances as we make these parts. We talk about the machinability of steel alloys. So tougher, stronger materials are more difficult to cut. So tool steels, especially A2 or especially D2, is very difficult. Materials like Inconel, titanium, some of these have their own special properties that you have to pay attention to in the actual cutting process. And obviously, there are a variety of different reasons for using low carbon steel, high carbon steel, um, tool steel, uh, castings versus forgings in this particular process, depending on what the actual performance requirements of the part actually are. So we have mentioned before how the specifications on our steels do have machinability ratings. So, and the higher the machinability rating, the easier that material is to actually cut and process. So, it's also less wear and tear on cutting tools. So, those cutting tools will show less galling, and that's where, of course, galling is the wear between two surfaces where they're rubbing and sticking together. You can usually see that picking up as a machinist in the lab. We can take a look at our inserts or our cutting tools, and some of those, if they've been highly used, you'll see galling, especially on cutting tools where we've used and cut aluminum. Um, and a lot of times the material itself will pick up and flake on the actual cutting tool as well. Free machining steels are steels that have either sulfur or lead added, so that makes these easier to machine. So that iron sulfide and lead causes chips when in the metal cutting process to actually break easier. So we get those ideal perfect machine chips that come in little curlicues in the shape of sixes and nines with that type of material. However, there are limitations on using that. So if we are using sulfur based free machining steels, we can't hot work that material. So, and of course, we should not weld any of those materials either, because in the welding process, we might release the lead fumes that would cause other types of problems for anybody that's doing that particular work. We'll go on. There are lots of things. One of my pet peeves in labs is people not being aware of grinding wheels and pedestal grinders having specific uses. So we typically do not want to mix grinding wheels for harder metals with aluminum or even materials like wood. So those materials like wood and aluminum will clog up the wheels that we're using to grind our cutting tools and grind our steel that we're actually cutting, and that can kind of cause a lot of cutting pressure and damage those wheels. And of course, if the wheel becomes too damaged or too compacted, those wheels can explode. So it's very, very important for us to make sure that we take care of the grinding wheels in the labs here at both in the sim lab as well as over in the welding shop too. Polishing, we can basically get a nice mirror image and a surface finish that's very, very mirror-like in a lot of different types of metal. Oftentimes, this polishing is done either through lapping plates or honing of the machine, or in some cases, we are using polishing grit, real fine type of diamond compound that we use to put on stones and polish and get that type of mirror finish. So, lapping and burnishing are some of the polishing procedures there that we can use for that. Obviously, control and corrosion is important for all of these. Steel is going to rust in the outdoor air, so I'm going to kind of stop the video here at this point. So we're going to kind of say, all right, I've finished talking about the machining processes. Then I'm going to kind of come back and we'll finish off with some of the ways that we can actually control corrosion on these finished parts.